time to time get a little confused about the this keyword. And one of the reasons people get confused about it is because it means something different in JavaScript than in most other programming languages. So you actually have to kind of fight your existing knowledge. So if you're coming from another programming language, the best thing you can do is kind of just leave everything you think you know about well, a lot of topics, but in particular about the this keyword at the door. And if you are just coming to JavaScript as your first programming language, then you might even have a slight advantage here because you won't have to fight yourself in what you think you know. But simply put, the this keyword in JavaScript represents the way a given function is called. The way a function is called will determine what this represents. Okay? So you essentially bind the this keyword to a given context, and we'll explain what that means, based on how you call the function. All right, so up to now, we've not really paid much attention to how we call functions. I told you there was really only one way to call a function, using the method invocation operator. So we would do something like this a little bit later on, right? Like a car.printDescription, all right? And I used the method invocation operator, and I didn't even hint to the possibility that there would be another way or multiple ways to actually invoke a function, but that's actually pretty important when you consider what the this keyword represents. All right, you're going to learn in this video at least that there are other ways to call a method that allow you to set or rather bind the this keyword to something so that you can do something interesting inside of, in this case, your object or your function or whatever the case might be. Now, you may never need to do this, but it's important to understand the basic rules and how this keyword gets bound to a context and gets referenced inside of your object or your function. There's an entire book written about how this functionality works and all the permutations, and it's awesome. It's a little bit over my head at times. So I'm going to give you an absolute beginner's explanation as to how this all works, but it should serve you well as you're getting started, and then you can refine your understanding a little bit later on. But let's start out by commenting out everything. And you know what? There's a really easy way to comment out everything that I haven't talked about yet. Alt, Shift, and A on your keyboard will add a beginning and an ending code comment character operator to whatever you have selected. So that's a nice quick way to do that. Great. All right, so let's start really simply. I'm just going to create a function called first. And this function is going to return the value of this. What is the value of this? Well, here, if you go console.log, first, is it equal to the global object inside of Node? So the global object, we'll talk about that a little bit later, I guess. It is kind of the most basic context of things that get executed inside of. So when we create something in the global namespace, a global variable, we would create it essentially attached to the global namespace. It's available everywhere in our application, all right? So let's see if when we call first from line number 20, is this, which gets returned, equal to the global object. So let's go this dash keyword, and it is true. All right. So when I call the first method, basically from the global context, because I haven't created it inside of using the module pattern inside an IFI. Remember what we talked about previously? So I'm basically just calling this here out in the global namespace. And what gets returned back is the fact that this is equal to that global namespace. All right. So now let's try something else. Actually, let me just do this. Let me copy this little comment that I have in my notes because it might be helpful to you for reference. All right. So let's start with another code example now. function second. And the only purpose of this is just to show that there is this little flag called useStrict. There's a strict mode in JavaScript. We're not going to go into it much, but this will change how this keyword is bound. And so if you have useStrict turned on and you try the same thing that we just did here, in fact, let me comment all this out using that Alt-Shift-A technique. And we essentially do the same thing here where we go console.log and then second equals global. Let's see if we get what we think we're going to get from the first time around. False. All right, well, I happen to know that it will equal undefined. And that is a true statement. What gets returned from this when we use useStrict is an undefined value. It gets bound to essentially nothing. All right. So just keep that in the back of your mind. The rules around binding the this keyword change depending on the context. In this case, the context is useStrict. It will fundamentally change how it works. All right. So with that out of the way, let's move on to the next example here. Let my object equal, and I'll create a property called value and set that to my object. And then I'm going to use create a global variable called value. And I'm going to set it on the global object by doing this global.value. At this point, I've created a new property on the global object, and I'm going to call this global object. All right. Again, in Node, this has special significance. If you're doing web development, it's actually window, and we'll look at that here in just a little bit. All right. So now let's go function third, and we'll return this dot value, and then we'll do a console.log third. So by default, what do you think will get printed out? Will we print out the value of the global object, which I set to the string global object, or the value of my object, which is set to my object? Well, hopefully, based on what we learned in this first example, you already know where I'm going with this. And because we called third from the global namespace, when we reference this keyword, it's referencing this global variable. So when we grab the value property, it's grabbing the value property of the global variable, thus printing out global object. Let me show you that there are other ways to actually invoke the third function, and we can control the binding of the this keyword like so. So here we're going to console log, and then I'm going to call third, but I'm not going to use the method invocation operator. I'm going to use the call method or the call function of the third function. All right. So it has a built-in method called call, and there I can pass in my object. And this is how I will bind this value to my object, so the value will be pulled from my object, not from the global variable. So let's save that. Here, let me actually comment this one out. Save it, and let's run it. Okay, hopefully that makes sense. There's another similar function called apply, and they're very similar. And in this context, won't be obvious how they're different because I don't have any additional properties to send in, or rather input variables to the third function. So if I had something like name, I would use then like call dot, Bob. But this can also take an array here in the apply, which could include Bob. So just do this. See what we get. I haven't tried this beforehand, so yeah, object Bob. Okay. Now, just out of curiosity, what would happen if we did this? Probably nothing at all. It'd just be blank. Yeah, object undefined. All right, global object with the word undefined next to it. Okay, so hopefully that makes sense, what I just added on there. That's really to illustrate the difference between call and apply. And so if I had multiple input parameters in the call, I would just add them on there. If I had multiples, I could add them on inside of an array. All right, that's the only difference. Okay, but let me just kind of annotate this and talk through it just for a moment. So just to kind of recap this, the this keyword depends on how a function is called, and an object can be passed as the first argument to call or apply, and the this keyword will be bound to it, like we did here in lines number 54 and 55. All right. And so just to kind of remind you about this, I'm going to go ahead and say this property is set on the global object, and then kind of works inside of here. This will return something different depending on how we call this method, right? And then I just want to add this little annotation here as well. Both call and apply allow you to explicitly set what you want to represent this, or how we want to bind this. The difference is how the additional arguments are passed in, like I show you here. Okay. So when it comes to calling a method of an object, the call site will be the object itself, and all of its properties are available to this. In fact, if we take a look back here, that's what happened. That's how I did this and why I use this.make and this.model. Again, when it comes to calling a method of an object, in this case print description, the call site, in this case car.printDescription, will be the object itself, and all of its properties like make, model, and year are available to this inner function only when I use the this keyword, because this represents this context. All right, because I'm calling print description using the car object. All right, so to call the function, I would use the object reference. That object reference car gets bound to the this keyword. So to further illustrate this idea, let's do this. I'm going to actually select everything we've done from here down and Shift Alt and A. And so let's go function fifth. And here I'm going to go console.log and this dot first name and a space and this dot last name. And hopefully this will make a lot more sense. All right, so now what I want to do is create two objects. So let customer1 equals, and we'll go first name colon Bob, last name colon Tabor, and then I'm going to create a print property that's going to point to the fifth function, like so. All right, and I'm going to copy this and just duplicate it. I'll make this customer2. Call this Richard Boughton. All right, and then finally we'll go customer2.print. customer1.print. All right, so now look at how this works. What is the context? How do I call the print method that's pointed to fifth? Well, in this first case, I'm using the object, if it'll let me get in there, object customer2. That is the context. We're going to bind the this keyword to customer2, because I'm calling it as a property of customer2. I'm going to bind next in line number 85 the this keyword of the print method to customer1. So let's go ahead and So to me, this example is really interesting because the call site is the object's reference to the function, and the this keyword can be used to reference the various properties of the object that was used to call the function. So it becomes an interesting and elegant way to essentially pass values into a function without defining a bunch of input parameters to the function itself. All right. So now what I want to do is kind of stop working with Node for a little bit and look at the this keyword in the context of a web page. So I've created a new this-keyword.html. I can use the term doc. You can see that when I type in the word doc, it's an Emmet abbreviation. If you're not familiar with Emmet, just search for it online. It's basically a shorthand syntax for, I guess you could say, for snippets for code editors, right? So when I hit enter on the keyboard, it kind of creates this, bam, this whole document outline for me. And it has some replaceable areas like the device width and the initial scale and the content and all that business. I don't want to change any of that stuff. What I do want to do is add a script section here near the bottom for reasons I'll talk about in another video. And then what I want to do is above that create just a simple button. So here we go, button, and inside the button I'm going to say, hey, click me, and then I'm going to set a onClick equal, and we'll come back to that in just a moment. Here I'm going to actually create a function that I want to call whenever the button is clicked. So function, and I'll give it a name, click handler, like so. And inside of here, I'm going to go, first of all, I'm going to allow something to be passed in. I'm going to allow a value to be passed in, and then I'm going to print out whatever that is to the console. So console.log arg. All right. Now, we'll come back to this in just a moment. I'm going to leave a space and go console.log this. All right. And then in here, I'm going to say the button on click equals click handler. So I'm going to call the click handler. I'm going to pass in this, the this keyword. All right. So if all goes well here, I should just be able to right click on this and say reveal in Explorer. And then when it's in the Windows Explorer, I can just like hit the enter key on the keyboard to actually open it up in my default browser. And what I want to do is I want to use the F12 tools in Edge. I'll bring up this little window at the bottom here. And I want to look at logs. So make sure that you're on the console tab and select the logs subtab. I'm going to click the click me button. And we'll see the results of both of our console.logs. In the first case, what we get back is the this that was passed in as arg and printed out directly to screen. And so in this case, the this keyword will reference this entire element. All right, so let's take a look at that again here. You can see how button on click gives me the whole thing. So I can do something like this, which if you're familiar with web development, should not blow you away. I should be able to do arg.innerText, and if you're familiar with web development at all, you would expect to see what there. Let's refresh the page, click the click me button again, and you see click me. All right, that's the inner text of that button. So I'm able to get to all the properties of this button, but the key here is that the this keyword represents this entire button, and I'm passing the this keyword in so that I can look at this entire button, inspect it, grab a property out. But when I use the this keyword inside of my click handler function, what do I get? I get the global object. Now we said in Node, the global object, the name of it is global. In a web browser, the global object's name is window. So I can actually just like use this little arrow, this little caret, chevron right next to object window, and it will allow me to view all of the objects, the child objects of the window. And there are literally maybe, if not hundreds, definitely dozens of different objects and properties that we can inspect and change programmatically. We'll come back to some of those ideas a little bit later. But basically, the takeaway from this is that whenever code is called from an inline on event, like on click, on event handler, this is set to the DOM element on which that listener is defined. That's why we got back this entire button, including the text, including the closing button tag. But we've not taken any special steps to bind this inside of this function we've defined here, the click handler. So it defaults to the global object, the window object. Okay? So the moral of the story is that what this keyword is bound to is not always obvious. It takes a bit of detective work, more so than the this keyword in other programming languages, but it has to do with how a given function is called and the site from which it is called. So in this case, this keyword is used at the call site is at this element level. In this case, this keyword is used at the global level, all right? And that will change the value of this and what it's bound to. But by default, functions that are called using the method invocation operators alone will use the context in which the call is made. So if the call is made in the global context, then this keyword will be bound to the global object. If the call is made in an object, then, like we saw here near the end, this keyword will be bound to that particular object. And we were able to use it to grab out the values of the given object, all right? And you can take control of what this keyword is bound to by calling it using either a call or the apply method of a given function. And we talked about what they do and how they're different. And finally, whenever you use them in use this keyword in a browser, once again, what this is bound to depends on how it's being called and who is calling it. All right. So hopefully that clears up what this keyword is. I've given you a lot of examples. I've tried to speak a little bit more slowly, and hopefully you can wrap your mind around what this actually is. And hopefully from this point on, you'll be able to identify what this is in your code. All right. Hopefully that helps. All right. You're doing great. Hang in there. We're getting close to being we're more than halfway done, and you're doing awesome. See you in the next video. Thanks. In this lesson, I'll briefly demonstrate how to use destructuring, which is a fairly new technique in JavaScript for unpacking values from arrays into individual variables, or I guess into other array elements of a different array. But you can also use it to unpack properties from objects, again, into other distinct variables or a different object. So use this term unpack. You'll see what I mean here in just a moment. Let's start by creating a new file called destructuring.js. All right. And the first thing I'm going to do is create a bunch of loose variables here, just A, B, C, D, E. We'll wind up using most of these at some point. And then I'm going to borrow that array that we created a while back. Maybe recognize some of these names. And then next up, let's start by just destructuring this names array into a set of variables. So I'm going to start off by using names, which I know is an array, and I'm going to use this bracket syntax and say, take the first element of the names array and stick it in A. Whoops. There we go. In A. Take the next element, stick it in B, C, D, and I could even change the order. Instead of D and E, I'll go E and then D. All right. And so let's just do console.log A, console.log B, and then console.log D, because that's a little bit more interesting. We'll just go ahead and print out C as well. Why not? And then we'll go E. All right, and so here we'll go node destructuring. All right, so take a look at what happened. We have this array. We destructured it down to a set of individual variables. And we start off with A representing David, the first element of the original array, Eddie, the second element of the original array, Alex, because we're grabbing them off in sequence. I did something a little bit interesting here, and so much that I switched E and D so that E will represent Michael and D will represent Sammy. When I print them out, going back to alphabetical order, D, then E, Sammy's first, then Michael. All right, so, but the key to this example is that I've taken everything inside of an array, and using this style syntax, I've destructured it down to individual variables. All right, so that's just one example. There's some other interesting ways to work with this. Let's just go here. I'm going to take all this, Alt-Shift-A, comment it out. And the next example, I'll do a let others. So I'm adding an additional variable here in addition to the other ones that we created originally. And here I'll go A, B, and then I'm going to use this weird syntax of ... others. All right, equal names. So now console.log A, console.log B, and then let's see what gets put out into others. All right, so this time A is from David, B is Eddie, just like before, but this time I said basically everything else, just go ahead and stick them in a new array called others. All right, so that's what we see here printed out from line 21. We get this array representation in our console.log, including Alex, Michael, and Sammy together. All right. So that's just another twist. We can basically take some elements one by one. We can then also kind of combine together entire groups of elements together. Let's move on to another interesting twist on destructuring. So in this third case, what I want to do is actually work with an object. And so whenever you're working with objects and you're destructuring out of one object into variables or even into another object, it's really like a form of projection if you're coming from other programming languages. Grabbing out the parts that I want of the original object and putting them into a new object with a different shape, all right, without having to take all the contents of the original object. So I may only want one or two properties where the original has 10 or 20 properties. So here, let's start off with just saying let year and model. Then I'm going to start off with car equals, but I'll get rid of that here pretty soon. We can start out with let car equal, but it won't matter because we're going to remove that. And I'm just going to create a typical old object, like let's say it's BMW. The model will be a 745 Li. The year will be 2010. The value will be $5,000. All right. And in order to destructure this, what I'm going to do is actually remove this and say, hey, I want to take the year and the model and put that into a new object of its own. And then what I'm going to do is wrap this whole thing in a set of parentheses and then an end of line character like so. So now we'll do console.log year. That'll be the value here that I'm pulling out. And model. It'll be that value there that I'm pulling from the original object and printing it out. So let's see what we get. All right, so 2010 from line 34 and the 745 Li from line number 35. All right. So that's just some examples of destructuring. Pretty simple concept. It really is just a compact syntax that helps to clean up code whenever you're trying to map from one data structure into another or into a set of variables. And that's all that it is. All right. So hopefully that made sense. We'll see you in the next video. Thanks. Another new feature of JavaScript allows you to create better literal strings through the use of templates. So the term template literal is a kind of oxymoron. Parts of the string will be literal and parts will be templatized. They'll be variable based on an expression, and so you can inject in other values, variables, or you can actually run entire expressions. And we'll see the use of a ternary operator in just a moment. Let's start off pretty simple. We'll begin by creating a new file. Call this template literals.js. Inside of here, I'll do something really simple. Let name equal Bob. All right, that's not the template literal. This will be console.log. And now I want to use the backtick characters, usually over the tilde. If you're not familiar with that region of your keyboard, it's usually right next to the number 1, 2, 3, 1, right next to the number 1. You'll have to hold down the shift key to get to it. So there's one backtick. Whoops, I'm sorry, you don't need the shift. The backtick key, all right, usually above the tab key on your keyboard. And so inside of there, I'm going to use hi. And then whenever I want to add something variable that will get kind of injected in from the outside, it'll be interpolated from outside of this, I'm going to use the curly braces, and right before the curly brace I'm going to use the $ character. So you can see that the syntax highlighting in Visual Studio Code changes the color of this to this bright blue color. That's cool. And so then I can just say, hey, I want to use the name variable inside of there, like so. Okay. So we should be able to do something like node template literals, like so, and I get hi Bob. Awesome. So the other cool thing about template literals is that they will allow you to create multi-line strings. Now before this, you would have to do a lot of using the append operator and so on, but in this case, you can do something like, and I'm just going to copy and paste this because I don't want to type all this out. You can see here that I start my template literal with a backtick, and I end it with a backtick down here at the bottom. So I'm setting this sentence, or sentences, actually this paragraph, equal to this whole string, and I split it up on multiple lines. And there's no append character or anything like that. What I can do is console.log sentence. And the neat thing too, at least from what I'm concerned, is that it preserves the indentation level and the line feed character. So, you know, I could do something a little more, I guess, artistic here. Come on, let's do this just with spaces like that. And it preserves that indentation level that I have. Pretty neat, right? All right, and then the other cool thing is that you can do anything inside of the expression interpolation area that you can do in a normal expression. And let me comment all this stuff out. Alt-Shift-A. And here I'm going to create a function, real super simple function. Get reason count, just a very pithy, silly idea here. And I'm going to hard code this to return the value 1. All right. And I'll change that a little bit later so you can see the difference here. But I'm going to create a variable called interpolation. Interpolation equals, now I'll use the backtick character give me $ curly braces, we'll come back to those in a minute, to try this. All right. Inside of here, make some space for myself. I can create any expression. I'm going to use the ternary operator. And so I'm going to say, hey, if get reason count, just because I wanted to make things a little bit more interesting, so I'm actually calling a function. If it is equal to 1, and here's where the ternary operator comes in, I'll say one good reason, otherwise a few reasons. All right, and this is starting to pop over out of the viewable area, but hopefully you can kind of keep track of using this syntax coloring. You can see where the expression interpolation begins and ends. Inside of that, here I'm going to evaluate the call to get reason count, and if it's equal to 1, I'm going to inject that part of the string in here. Otherwise, I'll inject this part of the string inside of my template literal. And now, I guess the only thing left to do is just a console.log interpolation, like so. Let's go ahead and actually run this. So give me one good reason to try this. Well, maybe we should try 2. Give me a few reasons to try this. All right, so you can, and I see the need for this all the time, especially in web development, where you may have 1 item in your shopping cart or 2 items in your shopping cart, to change up the string that gets outputted to for the end user based on a quantity. All right, and probably other good uses of that as well. So string template literals are a nice addition to the JavaScript language. Here again, they can make your code more compact and readable, allowing you to do some interesting things in line that would require a lot of appending of strings previously. All right, so doing great. Let's continue on. See you in the next video. Thanks. Regular expressions allow you to create a pattern to determine if a given string matches that pattern that you created. Regular expressions, or they're often just referred to as regex or regex, are not exclusive to JavaScript. They've been around forever. They can be used in just about every programming language. And I absolutely hate talking about them because they make my head hurt. I've not committed the syntax of regular expressions to memory, and so pretty much creating a pattern to find something is hard for me. And I've developed a few little crutches through the years so that I can, approximate or fake my way through the usage of regex, and I suspect you'll probably find yourself doing that as well, unless you're one of those really annoying people that just commit to learning regex inside and out, and then can impress people at parties based on that knowledge. So I try everything I can do to avoid memorizing it or learning the syntax. Usually if it's something simple like making sure that a string matches the pattern of a phone number, a zip code, something that's fairly common, especially with data in the United States, I can usually find a good example of what I'm looking for online using a search engine or Stack Overflow. But if it's something custom for the given project I'm working on, then I have to go and relearn just enough regex to get through that project, and then I try to purge it from my memory again. So I'm going to show you where to go, how to find the answers, and cobble together your own little regular expression. But I'm not going to pretend like you should go out and memorize any of this. I know people have done it, but I usually wind up hating those people because they're smug know-it-alls. But I digress. Let's just take a super simple regex example and use it in JavaScript. So I'm going to start by creating a new JavaScript file called regex.js. And here we're going to say, I'm going to create a simple variable called pattern. And you can create a regex pattern by beginning and ending with a /. So in this case, I'm just going to say, hey, search for this pattern where there are exactly these three characters, X, Y, and Z. All right. Super, super simple pattern. You would almost never use something this simple unless you were looking for specifically the letters X, Y, and Z inside of some long string that you want to search through, or a series of strings. All right. But there's my pattern. And so before we get started in earnest, let's just say, hey, what are you really? First of all, I want to print it out, and then I want to console.log, see if we're working with a new data type, or is this just a data type that we already know? So let's go node regex, and looks like just attempting to print it out will just be a string representation of the pattern. The type of the pattern is object. Okay, so it's a special built-in object to JavaScript. We'll talk about some of those global objects. This is just a shortcut to creating an instance of that global object for regex patterns. Okay, so here, let's continue on now and actually create some text that may or may not contain that pattern that we've defined. So let value equal, and we'll go, this is XYZ, a test. All right. And so what we can do is there's a couple of methods built into both strings and regular expressions that allow us to use regular expressions against a string, or use our pattern against this value, in this case, this variable called value. So we'll start with the console.log, and we'll use our pattern dot, and IntelliSense shows us there's actually quite a few interesting things that we could use. I'm going to keep this example simple and just say use the test method. And so IntelliSense tells us that this will return a Boolean value that indicates whether or not the pattern exists in a search string. So what I'm going to pass in is the string I want to search through. So in this case, value. And I would expect to get back a Boolean, a true or false, if we can find XYZ in that string. So let's save it. I'm going to comment out these guys. Now I'm going to save it. And now I'm going to get back here and go node regex. And it is true. We do find XYZ, our pattern, inside of this string. So I'm going to comment that out. The next thing that I might want to do is actually replace that pattern that we found in that string with some other string. That's pretty useful. And I do that sort of thing a lot in software development. And this time I'm going to start with the string itself, say value.replace. And so that string's replace method has the ability for me to give it a pattern. And then I also want to give it the value I want to replace. If I find that pattern, replace it with this string. And I'll just use the word just. All right, like so. This is just a test. So I've removed XYZ and I replaced it with the word just by using the replace method of the string, passing in the pattern and the word. Okay. There are a couple of other things. Those are the two that I find myself using most often. Here we can do something a little more interesting, I guess. Log value.match, and this match function will return back an object that it gives some information about what the string was, what the pattern was, if it was found, what the indexes in the string, like if you were to split it up into individual characters, at what point in the string would we find an instance of that pattern match. So here we're going to pass in the pattern itself. So I'll save that. And you can see it gives me back this array with the pattern we're searching for, the index where we can find it. So I think 0 is T, so 0, 1, 2, 3, 4, 5, 6, 7, and 8. So the X, the beginning of that pattern, is found at the ninth character index 8. Oh, I guess it would be seventh character. No, it's the ninth character index 8, right? So at any rate, and then the original input was the entire string itself. So we can actually modify this, or actually grab that object out and work with it individually. So value.match and pattern. Now that I have that array that we saw down here, I can grab an individual part of it. So console.log, and here I might go match.index. So it just shows you how to get an individual part of it. So here I can grab the index itself, and I could use that to do some sort of custom replacement logic if I wanted to do that. I'm not sure I would ever want to do that. Okay, so now this comes to the part where I teach you how to cheat. And if you really want to cheat, you go out to your favorite search engine and you type in something like zip code regex, and then if you're lucky, Bing will pop it up to the top, whether it be from Stack Overflow or just gives you a nice little usage example right there in line. That's a little dangerous because you don't know if this particular example was voted up or down. You might want to go and actually search through the comments and see the one that gets the most upvotes and the selected answer, and the one that doesn't cause any argument in the community. The other way is to go and kind of trudge through this yourself by looking at this page that, and there's plenty of references out there. I prefer the developer.mozilla.org website personally. I think their documentation is awesome, and here you can learn about the various special characters and regular expressions and try to cobble together your own regular expression to find what you're looking for. But that's all you're going to get out of me. That's all I can tell you about regex because I'm not a big fan of it. But at any rate, just to recap what we talked about in this video, you can create a regular expression, literal, with forward slashes. You can use the regex's test method, passing in a string to see if that pattern exists in that string. You can use the match method to find more details about the match. You can use the replace method of the string to replace a given match with some other string, like we did when we replaced XYZ with the word just. And then, like I just showed you here at the end, I showed you how to cheat. You already know this. Look online whenever you need regex, help. Okay, so let's continue on. We'll see you in the next video. Thanks. Up to now, we've looked at a number of types. Can you remember them off the top of your head? We looked at string, number, Boolean, object, undefined, and function as its own type. And there are a couple of others that we haven't talked about yet. We'll talk about null later. And then there's symbol, which is new in the latest version of JavaScript. Probably won't talk about that in this course, but what I wanted to point out, though, when we were using string in particular, but this is true of the other of some of the other types that we worked with, it seems to have some methods that are available to it to do some interesting things. So, for example, whenever we looked at regular expressions, and let me just create a new file here called natives.js. Whenever we looked at the regular expression lesson, we did something like value, which is a string set to this literal string. This is XYZ attest. And we did value.replace. Well, how is it that this value has this dot replace method? We really never addressed that. How is it something like a string can have a method? After all, we said that methods are really just functions that are defined inside of an object. So that would make a string an object, right? Or no? But a string's a string. How can that be? Well, actually, both of those are true statements. The fact is that the types we've been looking at so far, like especially string and Boolean and number, are known as primitive types. These primitive types then have corresponding built-ins or natives that are functions that return objects with a bunch of cool methods that are added to them by JavaScript. So behind the scenes, JavaScript does something interesting. The JavaScript compiler will coerce your primitive, in this case, primitive string, into an object that's returned from a native string function with all kinds of cool stringy type functionality included. So actually, although we haven't demonstrated this yet, you could create a string using the actual string function to do something like this. And let me comment this stuff out here. And so notice what we did here. Let string equal new. Then here's our function, that built-in function string. Notice that has a capital S. We'll talk about that in a moment. All right. And then if we were to save this, and then let's go ahead and get down here and type in node natives. It works, well, kind of works almost exactly like a normal string. We'll get to that in just a moment. So before I address that specifically, I'm going to work with strings in this particular video and with the string capital S string function, the built-in, the native string. But what I'm about to say about strings is true whether we're talking about numbers or booleans or other primitives that have an equivalent native associated with it. All right, so I want you to notice a couple of things and we'll work through this. First of all, this starts out just like any other variable that we're assigning to a string, except we use this new keyword. And I'm going to explain what the new keyword means in the very next lesson when we talk about constructors. But basically, this is what creates a constructor call to this function. And then here we are calling a string function, capital or uppercase S in string. But isn't that bad form? Didn't you say, Bob, that we should create our methods with camel casing, and so strings should start with a lowercase s? Actually, this is a special situation. It's still a convention indicating that this is a function that should be called using a constructor call. Again, more about that in the very next lesson, so you'll get a part 2 to this. But just keep that in the back of your mind. We'll come back to it. All right. So whenever we run this, as you can see here, when we ran node natives, we didn't get an actual literal string output. Instead, we got basically an object that has a string property and a value set to howdy. We actually need to call a method on this native that's returned from the string function to convert it into a primitive string for the proper display inside of a console.log. So we'll need to do something like let me just comment this out, and we'll go to string, like so. And now, there we go. We grab, we convert that native, that object returned from our native string function back into a primitive string, and then display it on screen. Okay. So, and while we're looking at things here, just out of curiosity, let's go console.log and then go type of my string. What would you expect to see here? Well, it is a type of object. All right. So again, what's going on here is that these built-in native types provide extra functionality like this toString method, like this replace method, and others that we'll look at in other lessons. And they provide this extra functionality to their corresponding primitive types. And so just real quick, here's a list of those built-ins, those natives. All right, so it includes kind of corresponding to the primitive string, lowercase s in string, number, boolean. There's also an object, a function, and a symbol. And then there are built-in natives that do not have primitive versions. The primitive version, as you know, of array is object, and the same with regular expressions here, regex. But it does provide this native built-in with extra functionality for our arrays. So the same kind of thing happens, it's just not with directly back to a primitive. It's to an object, but it still works with anytime we're working with arrays. And then there are some other built-in natives that provide foundational data types, I guess you can say, for important features, but are essentially just objects whose methods implement a lot of logic for their features. So things like the date function and the error function. We'll look at these a little bit later. But in this lesson, I want to focus solely on the relationship between primitives and built-ins. So whenever we do something like this, and let me just copy and paste some more code in here. So here we're creating a literal string, and then on this literal string, I'm going to call this method toLowerCase. Behind the scenes, what's happening is that JavaScript's compiler is coercing, it's wrapping, it's boxing that primitive string, my primitive, into a built-in native equivalent in order to provide that rich set of methods that transform the string, in this case to all lowercase letters instead of all uppercase. So if JavaScript is coercing, wrapping, boxing our primitive into this built-in native equivalent, then what happens whenever we need to get a value back out of it? Well, the JavaScript compiler will do the opposite. It will unbox that object back into a primitive without you having to do anything special. It manages it all on its own. So in this case, let's just kind of see what happens here. Just out of curiosity, let's get the type of here, and we'll put the type of there. All right. And we'll see that when we run this. And let me make sure there's nothing else here. Let me comment all this stuff out too at the very top of that file. All right. So now let me save that. And we can see that it treats this literal string as a string here in line 31. Then in line 32, it does that unboxing thing that we talked about to take string, make it into an object so that we can call the toLowerCase method on it. And then what do we get back? Well, at the point when we attempt to find out what the type of my primitive is, it already has, for our purposes, essentially unboxed it back into just a primitive string. All right. So it's recommended that you stick with using the primitive and you allow JavaScript to do its magic. The compilers can do this sort of thing without breaking a sweat, so don't worry about all this boxing and unboxing and its impact on performance. But let's suppose that, just for the sake of argument, that you wanted to start out with a built-in native and you want to explicitly convert that built-in native version of a string into a primitive string. How would you go about doing that? Well, here, let's take a quick example. And let's go ahead and move away from strings and just to numbers, but the same idea will apply no matter what. So I'm going to comment all that out. Let's go let my number equals new number. Notice capital N or uppercase N in number, and then in the constructor argument we'll pass in the actual value that we want to set that number to. All right. So at this point, let's do a console.log, and let's find out what the type of number my number is. Have any guesses on what it will be? Let's go ahead and stop right there, and let's make sure we understand it's of type object at this point. Now I want to take it out of that built-in native, and I want to grab just the value of my number out and put it into a primitive. So here we go. Let my primitive, I'll just reuse that variable name here, equals my number dot, and then to grab the value out, regardless of whether we're working with string, number, Boolean, whatever the case might be, we'll use this method on this object called value of. So the value of method, and now we should do a console.log my primitive. Actually, we know what the value will be. What's more interesting is the type of. So now let's run that. And so here in line number 36, we're going to get, it's an object, but we use value of to retrieve the actual value of our built-in native object into a regular number. And we print that out in line number 38. Okay. So to recap, the point of this lesson is to explain what these functions are that have the same name as our primitive types, but with an uppercase